There are a lot of flat roofs out there. Just look around. Think of large warehouses, big surfaces. That rooftop space is where solar panels can be placed. And since the average commercial facility in the UK only uses about 30% of that solar energy, let's say that remaining renewable power can be sold to a data center, which uses a lot of energy. InRange can assist with just that. It's an AI-powered platform that simplifies and optimizes energy networks to unlock a new energy asset class. Joining me today is Noaa Cohn, who will tell us how it all works. Welcome, Noaa.
Thanks for having me.
It's great to have you on the Reimagined Energy Podcast. And with each guest who comes on, I love to ask the question, tell me about your background and what led you to your career in renewable energy.
Yeah, I have a long background in big data. So I worked at a few different companies, including Microsoft and Google, on big data platforms and services. And around 2021, I had kind of made the decision that it was time for me to make a shift into a more climate related field. And I thought, well, how are those skills, being a product manager in big data, going to be transferable? And then when I looked at the different kind of areas in climate that could be relevant, the energy transition really seemed to be a place where data and AI had a really big role and a very big impact, because they're like the physical technology, the solar panels, the inverters, in a lot of ways already the batteries, they're already there, but the ability to deploy them more effectively and be more effective in delivering that energy was really the place where data and AI was going to make a bigger difference. So that's where I ended up going.
So you right now you're currently at InRange, a
Correct.
company. So how did the company start? Doing what it's doing.
Yeah. So John Mushriki is our CEO, and he's a serial entrepreneur. And the last job that he had before founding InRange was at BP. And he actually reported to Bernard Looney, the CEO of BP, and was really kind of figuring out, had the charter of figuring out what is the digital future of renewable energies with BP. And he did a lot of understanding of what was happening in the market. And that's where he saw this big gap. So today, in the solar, in commercial and industrial buildings, they are highly underutilized when it comes to solar. About only 5% globally of retail spaces, commercial industrial warehouses, logistics facilities actually have solar on them. And John was like, well, why is that happening? He talked to a lot of landlords, a lot of tenants, and understood that that was the result of this kind of split incentive, a mismatch between of what was driving the adoption between landlords and a tenant. So a landlord wants to make money on their asset, and a tenant wants to save money on their energy. But given the very specific profile of commercial industrial buildings, which is that they tend to have really beautiful, big, flat roofs where you can put a ton of solar, generate a lot of energy. But relative to that size, the demand of the on-site tenant, that retail company, that distribution, logistics facility, doesn't really need to use that much energy, probably about only 30% or less of what that building can actually generate. So the installations relative to the roof size were actually quite small. So that installation is pretty expensive. These are, solar panels is quite an expensive installation, even with the dropping costs. And that resulted in pretty high tariffs, what the energy payments of the on-site tenant. So the tenant really wasn't into it. It wasn't cost effective enough for the landlord, and then it didn't happen. And that's where we see that 5% deployment. So that's what John set out to address in founding InRange. And his hypothesis was, when you align those incentives, you align the landlord and what they're trying to accomplish with the tenant and the savings they're trying to get, then that unlocks this asset class. And the way that his idea to do that was make the installation really, really big and generate much more energy than you need on site. And then take that excess, that surplus generation, and sell it to a guaranteed off-taker, say to a data center that needs a lot of demand. And suddenly the financial equation shifts.
Right.
The costs drop per kilowatt because you're having a bigger install. So every additional kilowatt you generate costs less overall, and you're making more money. And now you can offer the on-site tenant a lower tariff and continue to make money for the landlord. And that balance has shifted. The incentives are aligned and everybody wins. That's kind of the goal. And you install more energy, and that's how we're unlocking this asset class with InRange.
Why do you focus on data centers? I mean, you have a partnership with Iron Mountain, a large data center in Europe. Can you talk about a little bit about this relationship?
Yeah, so data centers are super, super key. I mean, as probably many of your listeners know, the energy demands of data centers are massive and growing. More than 3% of global energy demand is data centers. And with the rise of AI, these are only growing. And a lot of data centers also have sustainability goals. They don't want to be consuming all of this dirty energy. And so the nice thing about a data center is it's almost an endless need for energy. And on the flip side, if you look at what we need to be able to make an offer to a landlord, you need an institutional grade off-taker, someone that you can tell the landlord, hey, all your excess, I'm not just tossing onto the grid. I'm not sending it to someone that's going to fold in 3 years. I'm sending it to Iron Mountain. And that kind of covenant that data center has for that energy is really respected and trusted by the landlord, and then they're willing to enter that deal because landlords these are conservative kind of players, these REITs, and they're looking for that guarantee and that consistent revenue stream, and that's what these data centers can offer. So Iron Mountain have been amazing as a partner. Their director of energy and sustainability, Chris Pennington, really took a bet on us just out of the gate. And John approached him and said, this is our idea. We think that we can supply you with a really large amount of consistent, reliable, cost-effective energy. And Chris said, I see the value in this. And they're a really forward-thinking company. They were the second after Google to make a 24/7 carbon-free energy commitment. And so he said, okay, you bring me that energy, I'll buy it at this rate. And with that guaranteed offtake in hand, John was able to go to a commercial landlord and say, hey, Iron Mountain will offtake this. And then that's what kind of started the ball rolling. So Iron Mountain and their kind of forward thinking openness and support of new asset classes for renewable generation was super, super key. That partnership is super key for us to have been able to get the ball rolling. And since then, we've been able to expand and bring that offering further into the market for more data centers. But it's also important to note, not only data centers can be off takers. When we roll out, like for example, we're rolling out with the Range, one of the biggest retailers in the UK. They have hundreds of sites, and some of their sites may not be appropriate for solar for whatever reason, and they still want to buy clean energy and save money. And so they're able to take excess generation from one of their sites and sell it to another one of their sites. And so data centers got the ball rolling, but now that we are moving forward and deploying more sites, we're really creating this network of generators and off takers, and we're able to what we call supply and demand match between the excess generation and the different kind of demand nodes on the network that can off take it. So it started with data centers. Data centers are very, very key. Iron Mountain, very important partner in this process, but it's grown past that and into a networked model, a distributed energy network.
I love it. I think it's a great idea. And but what is the process for landlords? Like, say you have, a data, like, how does this all happen? You have a landlord, they want to get solar on their buildings within range. What are the steps for installation?
Yeah. So we are super tech enabled. We really believe in the role of technology, not just for the sake of having technology, but, because a lot of these landlords, these are not digital natives. It's not the first place they go is to a online product to solve these problems. But we really believe in technology as an enabler, an automator, an accelerator of energy deployment. So what tends to happen is we'll have contact with a landlord or REIT, which is a real estate investment trust, and they will have kind of our key customer profile is a landlord that has many, many assets. This can be hundreds, thousands of assets, including international. And they'll come to us with, let's say, 100 buildings, just like a list of addresses. And overnight, our platform will crunch through all of that data to look at each of those buildings and say, how much do we think that building will generate? How much demand does it have? Where is it? How much grid capacity is there next to that building so that we know that it can actually export? We do a lot of number crunching, a lot of data analysis, and we'll come back very, very quickly to them with, here's an entire analysis of your entire portfolio. And at the end of the day, these folks care about the financial performance of that asset. And so we'll say, here's the IRR, the revenue, the payback. These are the key kind of performance metrics that they're looking at in making a decision. And they'll say, here's the site that I want to move forward on. Sites, generally it's prioritized. And then they will bring on that tenant. So that tenant also needs to agree, because that tenant needs to say, yes, I'm willing to, I have a lease on that roof. I'm willing to transfer the rights to you. Yes, I'm willing to enter an on-site PPA, and I'm willing to buy that energy on-site at a certain tariff. And we will get additional data that makes our assessment more accurate. Like if you have the half hourly demand that your building has used over the last year or two, that will help make us increasingly more accurate. And then when the tenant and the landlord have agreed with us, yes, we want to move forward, that's when we go on site, make sure that the roof is in the state that it needs to be. Right. And we work with, we have a bench of EPC partners. These are installers, folks that go and actually do the physical installation. Once the physical installation is done, I mentioned, by the way, along the lines, we also do a grid application to make sure that we can actually export at that point. And then once it's installed, we take on the operations, the monitoring, the billing, the settlement, and the downstream data sales. So from the landlord and tenant perspective, the only entity they ever engage with is InRange. We have the relationships with the manufacturers, with the installers, the procurement, everything is on us. For the lifetime of the asset, tenants, get a bill every month and pay for it. The landlords, get a statement every quarter with the money that they've made from this installation across each of their respective portfolios. And for them, this is the simplest and most cost-effective way to do solar. And we're actually able to get 25% revenue increase over kind of doing it themselves with a traditional solar developer for the landlord, and 25% savings on their tenant, on their tariff from what they're getting from their retail utility for the tenant. So it's, like we said, it's a win-win for all of them. And they only have to deal with one supplier, and that's us.
Are battery storage options available?
Yeah, so battery, no, go ahead.
Yeah, no, like can people store what they're generating, and is it done on site? Like, how does that all work?
Yeah, so batteries are really super interesting because they can be used in so many scenarios and make really improve the financial offer that we can make. But it really depends on a site-by-site basis. So the first kind of scenario that we use a battery for, and the analysis that our platform does, is saying how much of the energy that is produced on that building can be used by that building. Because that on-site tariff, the tariff that the on-site tenant pays for the energy, is the highest that we're going to get. And so using a battery to kind of shift the generation from a time when it could have been exported so that it's used later in the day on site, that's kind of the first use case that we use a battery for. And the second use case is sometimes on export, there are times of negative pricing on the grid. And negative pricing can affect us even though we have an off-taker contract, because we are not a regulated utility. We work with supplier utilities in the UK, which is where we are operational today. And so we are exposed to negative pricing. And so what we can do is, if there's a negative pricing signal in the market, we are able to store energy instead of export it during that time, and then export it again when we're in positive pricing timeline again. So those are the kind of two places where really batteries are used for optimization. Now, that optimization is revenue optimization. You can make more revenue, or you can avoid negative revenue. And that adds up, and that's done as part of our forecasting. But batteries can often also be expensive. And so part of what our platform does, and that's why I said we use a lot of tech and a lot of data, is say, okay, if we do that shifting and we account for all of those improvements and optimizations, how much does that offset the cost of the battery? And how does that affect the IRRs? And there are some cases where there's already good utilization during the daytime of the energy on site, and that kind of minor shifting that we can do really doesn't offset the value of the battery. But as battery prices are dropping, they're becoming more effective, they're degrading less. Our modeling is showing that there are going to be more and more opportunities. And the great thing about batteries is, I mentioned two scenarios where we're modeling them today, but kind of the intermittent nature of PV is a big reason why batteries are so important, not only to our model, but to the energy transition on the whole. And one of the things that we're looking forward to doing is using batteries in more complicated ways and in more real-time ways. So, for example, we can use a battery to shape or firm the export. So, for example, if I can deliver energy in a particular shape, like let's say in the evening time, that might be more valuable than if I deliver it during PV hours, where, as PV proliferates, that the value of that goes down. So batteries really give us an opportunity not only to shape, but also, for example, to participate in ancillary services. So one thing that's happening in the UK is they're able to say, to dispatch batteries and say, hey, can you commit to a certain amount of energy? And I would be able to give you a signal. The grid would be able to give you a signal if it needs that energy at any given time, whether it's to balance the grid through the balancing mechanism, or it's part of frequency response to balance the frequency of the grid. And so there's a lot of emerging opportunities to really utilize batteries in new and valuable ways, given the intermittency of what's happening with the wind and solar on the grid, and also the need of the grid overall to balance. We're really looking forward to tapping into more of these opportunities with batteries, especially as their prices go down.
Exactly, because more and more there's development that's happening in the battery technology. It's getting better and faster all the time. So,
yeah.
What is the relationship between this AI platform and the utilities? You mentioned briefly the utilities earlier, but what's the relationship like there?
Yeah, so we are not a utility. So when we sell energy to our off-takers, we are not selling them as a utility, as in the UK, let's say, as an ENGIE or an Axpo. We rely on the regulated utilities to do the sale itself. So what we end up doing is having a relationship. It's called, there's a couple of ways that we can sell to an off-taker. One is a virtual power purchase agreement. This is kind of a financial instrument where they buy the energy and they get the certificates of having been generated renewable energy and the additionality of that, but they don't get the physical energy delivered to their premises. Now, what's called a sleeved PPA means that we work with their utility to sleeve the energy in through the utility. So that's actual physical delivery of renewable energy electrons into that site. And that's, we work with the utilities to make that possible. So that's how we're working with the utilities, and utilities love it because this is not a competition. This helps them to give a more cohesive and more robust renewable energy solution to their customers. They're not going to be able to generate this energy, and we're never going to be able to completely fulfill the needs of their tenant. And so they see it as a good value add to that energy buyer. We also work very closely, of course, with the grid. We need to make sure, first of all, that we get access to the grid for doing export, but also there's a lot of challenges right now with the grid in many, many markets of congestion. So there can be, let's say in the UK, a windy day and a lot of wind energy being generated in the north, and then a lot of demand in the south. And there's congestion along the transmission lines within that region. And the more energy needs to be transferred long range over that transmission network, the more congestion and challenges you're going to see. And they're actually paying billions of pounds per year to turn down generation in what's called congestion payments, so that is avoided and the grid stability is intact. And so there's kind of two parts to what we're doing that helps with that. And this is part of the conversations that we have with those DNOs, the distributed network operators in the UK. One side is we're bringing generation much closer to the point of demand. So as our network grows and we're able to match the excess from one site to the demand of another, the closer you bring them together, even if they're not within the same DNO, even if they're just the same physical region inside the UK, you're not necessarily using the same amount of transmission network. And so you can reduce congestion in that way. And the other way is we have full control over these assets. If I have a building that's generating 11 megawatts, and now there's a congestion situation in a particular part of the network, I can accept a turn down request from the grid where it cannot take all this export, even though it committed to me that it could. And then I can turn it down and actually, one, I can monetize on that. But two, I can also then load my battery instead of necessarily, I don't have to necessarily even turn off generation. I can load my battery and then I can monetize on the export later on. So we really find that interactivity with the grid and the more data that we share with the grid, the better, because, in every market, they're basically making a lot of plans around what to upgrade and where, and dealing with this onslaught of generation that's coming on in different locations. And so working effectively with the grid, again, is a win-win. It gives us more access to the network and it gives the grid more visibility and ability to maintain the stability of the grid over time.
What do the next 12 months look like for InRange? What's next?
So we are hyper focused on deploying as much energy as possible to our customers. And the more of that energy is deployed and live and flowing, the more we can do kind of that next stage, which is optimize its delivery. So part of it is being delivered to data centers, but then the more energy and surplus energy is live and available of our network, the more we can do that dynamic real-time shifting and loading and routing of energy. And every time you do that shifting and loading and routing, we're doing it because it can be more financially viable or it can reduce congestion. And so moving into that more kind of real-time dynamic network effect is going to be really big for us. And the second is market expansion. Like I said, these landlords and often even the tenants that we're working with, these are international companies. And so they are already kind of pulling us where we're really going, where the market is taking us into other markets. And so particularly in Europe and in the United States, because like I said, we're giving them kind of that one-stop solution. They only need to work with InRange from the first assessment of their site all the way to the billing and settlement and delivery of the electron to the off-taker. And they don't want to then have to work with someone else in a different market. They're like, if you're my one-stop shop in the UK, I also want you to be my one-stop shop in the Netherlands or Spain or Virginia. And so that's a big part for us coming up in the next 12 and 24 months is expanding into markets with our customers.
I have one last question to ask you, and it just popped up right now. But what about hospitals? Hospitals generate a lot of energy. Do you guys have any plans to work in that area in the future?
So I think hospitals, from my understanding, they have a lot of demand, right? Like there's a lot of equipment and probably quite complex roof structures. Hospitals tend to be built in wings, and then they don't have that nice, beautiful flat roof that you have access to. And so I definitely see hospitals as being a commercial use case of purchasing energy. For example, we recently worked with a manufacturer of toilet paper. Right. And they had a massive facility and they're constantly manufacturing. They have huge energy demand, but the roof was not in a state to put solar on it. And I think hospitals, and there's a lot of other use cases like that where they can benefit from buying solar energy through a sleeved PPA, working with us and their utility to reduce their costs and improve their sustainability posture.
Thanks, Noah. It was a pleasure having you on the podcast today, and I love the idea. I love what you guys are doing, and keep on, and I'll be keep in touch with you guys in the future to see how you guys are doing.
Thanks so much for having me.
Thank you for listening today. Give a listen to our other podcasts on our website at reimaginedenergy.com or our YouTube channel. The fine folks who sponsor this podcast is the Smart Energy Event, which is held annually in Halifax and in Vancouver. I'm your host, Maria McGowan. Thanks so much for listening, and bye for now.